I will begin my presentation with the topic of multi-junction solar cell. While solar power generation is slowing down in Korea, solar power generation is still attracting attention overseas. Solar power generation projects are even being promoted in the Middle East Asia, where fossil fuels are produced, and Korean companies are winning orders. In addition, despite China's dumping of solar panels, it is attracting attention again to the extent that Korea companies are expecting to turn up profit. Then, let's first look at why solar power generation is attracting attention. The energy that the sun sends to Earth is approximately 3,400 times the energy used by all of humanity. Even looking at the energy that reaches the Earth's surface, it is about 720 times greater than humanity's energy use. This is a truly enormous figure, considering that the total amount of energy contained in wind power is only 1.5 times the energy used by humanity. So, how solar power generates electricity? Let's take a quick look at how solar cells work. Solar cells have a p-n junction structure, and when light with energy exceeding the band gap enters, EHP is generated and this charge is divided by an electric field, creating a photovoltaic effect that generates electricity. Next, let's look at the efficiency of solar cells. At the device level, the most important factors that indicate efficiency include fill factor, series resistance, and parallel resistance. Fill factor is the maximum power per VOC cross ISC. Series resistance includes substrate resistance, contact resistance of cells and metal wiring, and wiring resistance. The larger the serial resistance, the more it affects FF, lowering the maximum output power. Parallel resistance is called shunt resistance and occurs due to defects in the manufacturing process. If a leakage path occurs due to a defect, the parallel resistance decreases and affects FF, lowering the output power. One of the important indicators of solar cell efficiency is quantum efficiency. External quantum efficiency is the number of electrons per second divided by the number of photons per second. The quantum efficiency of a typical solar cell is shown in the following graph. First, short wavelength light is absorbed by external glass or surface. Afterwards, the efficiency remains lower than ideal case due to surface recombination or short diffusion length, and as the energy of light approaches the band gap, the absorption efficiency decreases and light with energy below the band gap cannot be absorbed at all. Light from the sun has a continuous spectrum, but there is a limit to increasing efficiency because it can only absorb light in a specific wavelength range. Therefore, the method being studied in a multi-junction solar cell called tandem. For example, this solar cell was manufactured with a structure that stacks three junctions, achieving an efficiency of 39.5%. Each layer absorbed light with energies approximately 1.9 electron volt, 1.3 electron volt, and 0.9 electron volt. Next is a graph that allows you to look at trends through research that recorded the highest efficiency by year. The blue line in the graph shows that the crystalline silicon-based single-layer solar cell records a maximum of 27.6%, and it can be seen that the increase of efficiency is not continuous and is stagnant. On the other hand, the purple line shows the efficiency of a multi-junction solar cell, which is higher than that of a single-layer cell, and its efficiency has continued to increase until recently. So it can be judged that it still has a lot of potential. Lastly, the future of solar cell. According to the following article, we can see that Korea company is conducting research aimed at the mass producing next generation solar cells. This next generation solar cell is a tandem cell, a multi-junction based on perovskite. The efficiency during actual mass production is expected to be 35%. Additionally, the following press release is a technology roadmap for each key sector for carbon neutrality reported in December 2023. In this way, the country aims to develop tandem cell technology and is making efforts to increase efficiency through various other technologies.